Hi, my name is Brian. Welcome to our series on layout. We're going to start today with geometric construction. And geometric construction is a process of creating different shapes using geometry to help us in our layout process. And there's little techniques we can use to help us further that. So let's get started right off the bat here. And our first process we're going to look at is bisecting a line. So we start with a line of it doesn't matter the length, any given length. And what we want to do when we talk about bisecting something, we're talking about cutting it in half. So we're going to split it exactly in half. You could do this on a piece of metal if you wanted to break it exactly in half. And maybe it wasn't a simple measurement like 12 inches, which is easily just measured, 6 on each side. If it was something that takes a little more accuracy than that. So what we want to do is take and set our dividers to approximately 3/4 the length of the line. Now, you'll see as we go that the 3/4 is a ballpark. It's approximately 3/4. It doesn't need to be exact. What we want to make sure of is it's beyond halfway. And the further past half we go, the more accurate, because the further away our points are going to become. So I set to approximately 3/4 and I swing an arc from one side. And keeping that same distance on my compass, I come to the other side and swing an arc here. Now what we're looking for is the 2 cross points. And if we connect those 2 cross points, they will break that line exactly in half. And that's bisecting a line. The next technique we'll look at is bisecting an arc. So the same as bisecting a line, in the sense we're trying to cut an arc in half. And again, it doesn't matter of our radius or how long the arc is. That isn't the crucial point to the exercise. It can be done in a number of different ways. Now, the first thing we want to do is from the 2 points of the arc is join that with a line, and that line in geometry is called a chord. A chord is defined as a straight line between 2 points on an arc. Just going to freshen that line up. So now we've joined the arc with our chord. It goes back to bisecting a line. It's the same process. So we take our compass, we set it to approximately 3/4, and I swing an arc from one side, and keeping the same distance on my compass is very important. I swing an arc from the other side. Again, I join the 2 cross points where my arcs met. Gives me a bisection of the arc itself. It's exactly in half. Now I said earlier that it doesn't matter how accurate your 3/4 is as long as it's past halfway. So now we know where halfway is. If I set my compass less than halfway and swing that same arc, you can see that they don't cross each other. And what I need is the intersection of the arcs. But these two aren't long enough to cross each other. The longer I go, the further away those cross points get, which gives me greater accuracy. So anywhere I swing those, as long as I swing from the two outside points of the arc or line, and I keep that distance consistent from side to side, I'll end up with a cross point above and below. And if I join that, that's my bisection. The next process we'll look at is bisecting an angle. So again, we want to cut an angle in half. And it doesn't matter what the angle is. And if we think back to creating a perpendicular at the end of a line, we've really done this process already. So if I have an angle and I want to divide it evenly or bisect it, what I'm going to do is take my compass and I'm going to swing the arc that encompasses that angle. Doesn't matter where it is, it could be anywhere along that angle. Just something reasonable and something not too small, not too big. And then we're going to bisect the arc. So again, I have a point at the one end. I don't need to go through the bottom side, but I go approximately 3/4 of the distance. I swing to the outside from one end of the arc and from the other end. And when I connect those 2 points, this one we're going to what we refer to as the vertex of the angle. This is the vertex here. And now we've cut the angle in half, we've cut the arc in half. That's bisecting an angle. Next process we'll look at is copying an angle. Again, I'm going to set it, just tilt it a little bit, just to show that it doesn't matter. And it doesn't matter what the angle is. So I'm a little off the horizon. I don't know what the angle of I don't know what the angle is, and it doesn't matter. Now what I'm going to start with is just a flat line or a line where I want to copy my angle to. So I need some sort of a baseline. Now again, I'm going to take my compass and I'm going to set it to a reasonable distance, and I'm going to swing an arc. And since I'm set, I'm going to just go and swing that on my new baseline where I want the angle copied to. So I have that. Now what we said earlier was the angle is in coordination with the arc. So whatever the radius is and corresponding angle, those will always be the same for the same radius and the same angle here. So if I've taken my radius and I've swung it over there, if I now take the arc length, or really the chord, the straight line, because my dividers or compass is a straight line, and I pick this distance up, I'll transfer it to the other side. And now I have a cross point with the same arc length and the same radius, which means it's the same angle. Now our next technique is going to be creating a perpendicular line. And we can do this in a number of different ways. if I want a perpendicular in the middle of the line, if I bisect it, I create that perpendicular. So again, I'll go in 3/4. And notice now, I'm not swinging the whole arc. I'm just shortcutting it down a little bit just to get my cross points. Connect those 2 points and I have my perpendicular. Well, now we've created a 90-degree corner. The next way we'll look at perpendicular is anywhere along the line. So not necessarily on center of the line. In this case, we're going to take our compass and we're going to set it to a distance, and this one is really arbitrary. The distance just has to be something reasonable. I'm going to go just small here because I'm near the end of my line, and what I'm going to do is swing an arc both left and right of my original point. Now what that gives me is now equal distances, just as if I would have bisected this line. So now I have equal distance here and here. I can create a perpendicular from this point just by bisecting that section. So now I have 3/4 of the line. Swing above and below. Connect it, and I have my perpendicular. The last technique we'll look at for a perpendicular is creating a perpendicular at the end of a line. And this one's a little bit different. We're first going to take our dividers, and I'm going to set a distance, a reasonable distance. And I'm going to swing it from the point that I want the perpendicular at, from the end of the line. Again, the distance on my dividers doesn't matter. And I swing an arc. Now, keeping the same distance, the radius that I've used on my dividers, I'm going to come up to the start of the arc, and I'm going to swing a step off, what we refer to as a step off. When we take the radius and put it onto the circumference of the arc, that's a term we use as step off. And I'm going to do that twice. Just missed, so I'll bring that. It's all the same dimension, so I can easily extend that. So when we draw in a step off, what we've done here, I'm going to draw it in to show, is every time we take the radius of a corresponding circumference, we create an angle here. And what we create is 60 degrees. So every time we step that off, it's 60 degrees. So I have two 60-degree points here. And what we're trying to create is a 90-degree corner. The definition of perpendicular is a line 90 degrees to another. So we need a 90. So if I take 60 plus half of 60, or 30, I will create a perpendicular line. So how do I get that angle broken in half? Well, I'm going to bisect the arc, because the distance of the arc is what encompasses the angle. So the distance here will be the same as here because the angles are the same. Now on this particular one, I already have a point down below that I need to go to. So if I just cut this in half from up top here, and again I've gone 3/4 of the distance of the arc, and I'll swing an arc above. This time I don't need to go below, and I get 2 cross points up top because I already have the point down below, and I'll join that together. $60 plus 30 gives us our 90. Next process we'll look at is creating a parallel line. So a parallel line is one that is equal distance from another line, and they'll never touch. If we extended those lines forever, they would never come in contact with one another. So we have our line to start, and I've drawn it just as a slanted or tilted line, just to emphasize that it doesn't matter if it's flat or horizontal or vertical. It can be in any position. Now what I'm going to do if I have a required distance for the parallel line, that's what I'm going to set my dividers to. So if I need them 2 inches apart, I set my compass to 2 inches. And I'm going to set it on the line, and I'm going to draw an arc. So now I know that the radius, the very peak of this arc, is 2 inches away from my original line, and I'm going to do that twice. Twice is the minimum. The longer the line, you may want to do it more often. And it depends on how long your ruler is. But 2 points for each point of your ruler. Now we're going to line up our ruler tangent at the very, very peak, the highest point of those arcs. And I draw my parallel line. Copying an angle. The next process we're going to look at is called an arc through 3 points. Now these points are, in this case, totally randomized. And all of these techniques are just random techniques. We're just practicing at this point. They are all techniques that we'll use when we get into our pattern development. And these are the building blocks of that. So we have 3 points. And the first step is I'm going to draw lines in to connect those 3 points. And this just gives us a better visual. They're not really required, but it does give us something a little more tangible to look at than just 3 points on the board or on a piece of metal. So now there's our 3 points, make 2 lines. And what we're going to do is bisect each of these lines independently of each other. And I'm going to set my compass to about 3/4 the length of this line. And I swing my arc above and below. And keeping the same distance, I swing it from the other side. And I get those 2 points there. Let's connect those. And I draw my perpendicular through. I'll then bisect the second line. Again, 3/4, thereabouts, above and below. Above and below. Now you want to keep track of which belongs with which, and that's why I drew my first line in already, so that I knew this point went with this line. Now I'm going to connect these two. And what I really want is the intersection of those two lines here. Okay? And now that becomes my radius point for the arc that will run through 3 points. So I'm going to grab my dividers, and from this point, this intersection of my two perpendiculars, I set my compass to one of the points. Now, before I swing that, I set to 1, but I'm going to double check that it hits all 3. There we go. And that's just making sure that we haven't fouled up somewhere before I swing the arc. Arc through 3 points. Now, one of our most common techniques we use in our layout is dividing a circle into equal parts. And we do that with geometric construction. So I'm going to start with a line, because the first thing we need is an XY axis. So I'm going to set to 3/4. I'm going to bisect this line to start. Now, depending if you're in a drafting room or if you're in a shop setting, will determine if you need to use geometric construction for your XY axis, or merely just use your drafting board or tools out in the shop if you have the ability to get that square corner. XY axis, two perpendicular lines. So we start there, and now I'm gonna draw my circle. I could have done it in either way, but normally we'll always start with an XY axis. And I continue to draw the circle. There we go. Now I'm going to keep the same distance. I'm going to keep the radius on my compass. And even I'm switching colors, but I'm going to double check that it's still my radius before I do anything else. And it is. So what we said before is when I swing the radius along a circumference is I get 60 degrees. So if we drew a line back to this point here, I've created 60 degrees here. That leaves me 30 here. So I'm going to take that radius and I'm going to step it off above and below, or left and right of every quadrant location. Missed one. And as I do that, I end up with 3 equal parts per quadrant, 3 equal angles, 30, 60, 90, all the way around. And that gives me 12 equal divisions. And that is how we lay out anything round that's a fairly small size. Once we get up to a larger size, we divide it even more. But this is the most common that we'll use for any round object, like a piece of pipe, or a T-branch or a round elbow. Things like that will always require this process. Now, going along with our circle in 12 divisions, is dividing a line, or in this case a rectangle, into the same. And our commonplace here is, again, 12 divisions, but this technique can be used for any amount of divisions. Now, in a lot of cases, we can just measure and divide this in half, say, or even thirds. But it depends on the actual distance of it. And that, if we get into something really small and we want to divide this into 12 equal parts, and maybe it's something like 2 3/32 of an inch, to replicate that 12 times by measuring is a really inaccurate way of dividing that. So what we can do is, I'm going to use a technique called your ruler on a diagonal. Now, what we do here is I have my length, but it's not easily divisible by 12. I actually have about 24 and a half. So I don't even want to bother trying to calculate that out. What I can do is, I'm bound by the distance horizontally, but I'm not bound by the vertical lines. We want to stretch those out a bit. And as we stretch them out, it gives me the ability to angle my ruler further. So inside the rectangle, I may be able to go as far as here, but I don't have a clean number. I don't have a number that's easily divisible. So I can stretch it out until I do. And in my case, I'm going to use 30. And if I hold my ruler so that it's at the 0 point and at the 30 point, I can easily divide that by 12 by marking every 2.5 inches. And I put a tick at each spot on the ruler at 2.5 inches. And I always keep my lines vertical when I do that. You don't want your check mark coming out crooked. And now I can just square all those lines up. Each of the spaces are exactly equal. And again, it doesn't need to be 12 divisions, so we could do this in 6 or 9 or any number that we required. The component is finding that, getting your ruler on an angle where the number is easily divisible by the number of spaces that you want. Okay, so that's the key to this one. If you want it in half, then go to something, a whole number that's easily divisible in half. Or if it's thirds, pick one that's 9, 15, 18, things like that. So you find the number and then you divide that through to find out how much on the ruler you're going to tick off. Again, this one goes hand in hand with dividing a circle into 12 equal parts. Because when we take that circle and we stretch it out, it becomes a flat rectangle. Even a piece of pipe starts as a rectangle. And the numbers that we had, or the layout that we had on the circle in 12 parts, has to match the layout that we have on a flat piece of metal as 12 parts. So very commonly used. Again, elbows, T's, any round object like that we're going to make.